Hey, today we're going to be talking about how to solve systems of equations by substitution. Now, you've actually been doing this principle for a very long time. Remember seeing problems like, what is x plus 7 if x equals 2? Well, since x equals 2, we can take that 2 and we can plug it in to here. So instead of x here, we'll put 2, and then we still have our plus 7. So we have plus 7, and that would equal 9. So in essence, substitution is doing the same thing. We find out what one variable means, and we're plugging it in to an equation that we have. So in solving these systems, there's going to be three basic steps. First, you're going to isolate a variable. So you want to get a variable by itself. Basically, just like you've done solving for a specific variable. Next, you're going to plug that variable into the other equation. And then lastly, you're going to solve for your missing variables. Alright, let's do an example. Here we have two equations. We have y equals 3x, and we have x plus 2y equals negative 21. So our first step is isolate a variable. Well, looking at my equations here, do we have a variable that's by itself already? Yeah, look at this y here. This y is already solved for. We have y equals 3x. So now we've got a variable by itself. Second, we're going to substitute in this value into your other equation. So we have y equals 3x. And what we're going to do is we're going to plug this in to y. We're going to plug this into y. So now I'm going to rewrite. I get x plus 2. Now instead of my y here, I'm going to put it in 3x. So x plus 2 times 3x equals negative 21. So I just substituted in 3x for this y in this equation. Lastly, I'm going to solve. So this will give me x plus 6x equals negative 21. And going from there, let me give myself some space. We're going to get 7x equals negative 21. If we divide by 7 both sides, we'll get x equals negative 3. Alright, we've solved for x. Now we want to also be able to solve for y. So let's look at our original equation up here. Let me bring these back around. Here's my original equation. I have y equals 3x, or x plus 2y equals negative 21. It doesn't matter. Let's take this first one, y equals 3x. So if I have y equals 3x, I know that x equals negative 3. So I take that negative 3 and I plug it into this x here. And that is going to give me, let me give myself a little bit more space. That's going to give me y equals 3 times, and instead of x, I'm going to plug in negative 3. And that's going to give me, I'm going to do my work over here on the left, that's going to give me y equals negative 9. So now I have both my answers. I have x equals negative 3, y equals negative 9. And just like in any algebra problem, we could plug these back into here and check and make sure they're true. Let's try another one. Here we have x plus 5y equals negative 3, and we've got 3x minus 2y equals 8. So first, I want to isolate a variable. Now looking at my options here, let me find the variable that's going to be easiest to get by itself. Here I have x. Well, that doesn't have a number next to it. That might be our easiest. Here's 5y. That's going to be a little harder. 3x is a little harder, and negative 2y is a little harder. So why don't we solve for this x here? And because it's by itself, it's going to give us a lot less work. So let's rewrite that equation. X plus 5y equals negative 3. And if I want to get x by itself, I'm just going to have to subtract 5y from both sides. That's going to give me x equals negative 3 minus 5y. Okay, now I've got my x by itself. From here, I'm going to look at my other equation. Here I have 3x minus 2y. This is my other equation. And I'm going to plug in for x this whole thing, negative 3 minus 5y. So let me rewrite my second equation here. 3x minus 2y equals 8. And remember, instead of x here, I'm going to plug in this whole thing, negative 3 minus 5y. So that's going to give me 3 instead of x. I'll have negative 3 minus 5y. And then I continue. I have minus 2y equals 8. All I did was I plugged in for this x negative 3 minus 5y, which I got over there. Now I simplify that. This will give me negative 9. I have to distribute negative 9 minus 15y minus 2y equals 8. Solving from there, all we're going to do is simplify everything. That'll give us negative 9 minus 17y equals 8. Add 9 to both sides. So it'll give me negative 17y equals 17. And then I divide by negative 17 and I'll get y equals negative 1. Alright, now we have our y. Remember, what are we going to do from here? Well, we're going to have to take this new information we have, y equals negative 1. We have to plug it back into one of these original equations. It doesn't matter which one we choose. I'm going to go ahead and choose this first one here. So let me rewrite that. X plus 5y equals negative 3. All I'm doing is I'm rewriting this original equation back here again, because now that I know what y equals negative 1, I can plug in this negative 1 in for my y in my original equation, and then I can solve for x. So let's go ahead and do that. Let's say if we do that, we'll get x plus 5 times, instead of y, we're going to put negative 1 equals negative 3. This will give us x minus 5 equals negative 3. And then if we add from there, add 5 to both sides, we're going to get x equals 2. And now we've got both of our answers. We've got x equals 2, and we had y equals, I messed it up over there, but we have y equals negative 1. And that was what we got here. I just moved those on top of each other, but now we've got both our answers. X equals 2, y equals negative 1. Again, we can check it if we plug these values, both of them, back into any of these equations, we should get something that is true. Alright, that's about it, but let's take a look at a couple special cases. Not that you have to do anything differently, it's just you're going to see something interesting once you solve. So let's do this one real quick. 6x minus 2y equals negative 4. Y equals 3x plus 2. I already have my y by itself, so step 1 is done. Now I just want to plug in my y, my whole y value. I want to plug into this y in the first equation. So if I do that, I'll get 6x minus 2 times 3x plus 2. Remember, I'm just plugging in what I know y equals for y up here. So 3x plus 2 equals negative 4. Okay, let's go ahead and simplify this out. This gives me, oh, I almost lost my negative 4 here, equals negative 4. Okay, let's simplify this. This gives us 6x minus 6x minus 4. I distribute this. Negative 2 times 3x is negative 6x. Negative 2 times positive 2 is negative 4. And that's going to equal negative 4. Okay, now here's something interesting happens. When we combine our like terms, 6x minus 6x, those cancel out. We're not left with anything. All we're going to be left with is this over here, which is negative 4 equals negative 4. Since this is true, negative 4 does equal negative 4. What they had us do was actually solve two equations that were the same line. So remember when we talked about inconsistent, these equations is just one line on top of the same exact line. So when you get this situation here, negative 4 equals negative 4, your answer is just going to be infinitely infinitely many solutions. Infinitely many solutions. Remember, this is the special case when you cancel out your variable and you get something equals the same thing and it's true. Okay, we have one last special case here. We have 2x minus y equals 8, y equals 2x minus 3. First, do I have a variable all by itself? Right here, I've got y equals 2x minus 3. So let's take this 2x minus 3 and we'll plug it into this y. So rewriting our first equation, we have 2x minus, instead of y, we're going to put 2x minus 3. We're just plugging this in for y here, and that's going to equal 8. Solving for that, we're going to get 2x minus 2x plus 3 equals 8. Don't forget this, this negative here has to distribute, even though there's not a coefficient here. It's like there's a coefficient of 1 here, and this is going to distribute. So negative 1 times 2x is negative 2x, and negative 1 times negative 3 is positive 3. That's very important. Don't forget to do that. Then if we continue solving, we have minus 2x, or we have 2x minus 2x. Those are going to cancel each other out, and we'll just be left with 3 equals 8. Now, you should be scratching your head here. How does 3 equal 8? Well, it's not true. This is false. 3 does not equal 8. So when you get this case, when you solve and you get something that is not true, something that is false, your answer is no solution. You might have guessed that. No solution. Okay. Recap, remember, solving, getting one variable by itself, plugging it in. It's the same idea, the same thing you've been doing for a long time. Not too bad. Really try to keep your work organized. If your work is organized, you're less likely to make those simple errors. All right, see you guys later.